Okay, Assalamualaikum and good day. This video will be a quick one to review the trigonometric formulas. These are the trigonometric formulas, the 5 trigonometric formulas that you are familiar with, but need to do a bit of recall. So do remember that sin A cos B is equal to this. Okay, this is for sin A sin B. The third one is for cos A cos B. The fourth one is sin A plus minus B. Okay, that means if this is plus minus, here should be plus minus 2. And for the last one, cos A plus minus B, it will be this formula. But here the sign, take note, it will be minus plus. Okay, that means when it is plus, here should be negative minus. When this is negative minus, it should be positive plus. Okay, so let's look at the summary of integrals. So the first one, A. Integrate sin n pi x over L with respect to x from negative L to L would be equal to 0 for n equal to 1, 2, 3. Okay, let me show you a bit of the proof. Let's say, example, if we integrate from negative 1 to 1, here is actually sin n pi x over L, which is 1. Okay, respect to x is actually integrate negative 1 to 1 sin n pi x dx, and if we integrate this, we integrate sin would be negative cos. Okay, differentiate inside the bracket, it will be negative 1 over n pi, and here is cos n pi x. Okay, we need to substitute the value from negative 1 to 1, which means negative 1 over n pi, open the bracket, cos 1 n pi minus cos negative n pi. Okay, take note that earlier in the previous video, I did mention that cos negative n pi is the same as cos n pi. So that means cos n pi minus cos n pi is actually equal to 0. Okay, the same goes here. If you integrate and substitute the value of any L, you will get integrate cos n pi x over L from negative L to L with respect to x is equal to 0. Okay. Okay. The most important part will be for C, D, and E. So right now, we have here integrate sin m pi x over L cos n pi x over L from negative L to L with respect to x is also equal to 0, because this is an alternate trigonometric function. You can try it by substituting any value of n and n. You will get the value equal to 0. Okay. And next, for D and E, it will be a set of functions. C, D, and E are the set of functions sin n pi x over L and cos n pi x over L, which are orthogonal in the interval negative L to L. Okay, where n equal to 1, 2, and 3. For example, for D, integrate cos n pi x over L, cos n pi x over L from negative L to L with respect to x. Let's say the value of here, m, is equal to n. So that means it is equal to L. But if m does not equal to n, the value is 0. The same goes for sin. If m, okay, I think it's better for me to use the highlighter. Okay, if m does not equal to n, that means it is equal to 0. And if m equal to n, it is equal to L. Okay. So, let's look at two simple examples. Here we have integrate sin x sin nx from 0 to pi with respect to x. Okay, it is equal to 0 when n equal to 1 and pi over 2 when n equal to 1. The reason behind it is because here, okay, back to the formula here, we have sin x, sin nx. Okay, that means here you want to determine what is the value of m, right? So this is n. So what is the value in front of x? 1. So by right, m is equal to 1. So first, you know that your piecewise function would be 1 is when n does not equal to 1, and the other one is when n equal to 1. Okay, that's the first step. Okay, next, since n does not equal to 1, it's automatically equal to 0. And here, as you can see, it is actually L. But here is pi over 2. Okay. let's look at the value here. It starts from 0 until pi, not from negative pi to pi. So that means it is half of the calculation of the function. So that's why here it is L over 2. Why? Because it is integrate from 0 to pi dx. Okay, if integrate from negative pi to pi dx, so that means we can use L. Okay, it will be L. Okay, for now we have from 0 to pi, that's why here should be L over 2, which is pi over 2. Okay, that's for example 1. For the second one, we have integrate sine 3 pi x sine n pi x over 3 with respect to x from 0 to 3. Okay, the first step is to determine the value of m. M is equal to what? Okay, so right now we have sine 3 pi x sine n pi x over 3. The first step is to make sure that you have the same fraction. Okay, so here it is sine 9 pi x sine, sorry, I should add another thing. Let me erase this for a bit. Okay, it should be like this. Yeah, okay, sine n pi x over 3 dx. That means if for n need to divide by 3, for this term m should also divide by 3. So in order for this to be 3 pi x, so that means it should be 9 pi x over 3. Okay, that's done. That means we know that here m is equal to 9. Why? Because this value. Okay. Okay, right now we have two inequalities here. Sorry, not m, but n does not equal to 9, and 1 is n equal to 9. When n does not equal to 9, it's automatically 0. And then next, check here. It starts from 0 to 3. Okay, not negative 3 to 3. That means it's just half range 2. So right now, it will be L is equal to 3, right? Okay, so 3 over 2. Okay, because this one is actually should be integrate 0 to L. We refer to here. That's why here should be 3 over 2. Okay, if you have integrate negative L to L, that's why when we do the piecewise function, this one we will be using L. Okay, but when you have from 0 to L, that means it's half of the function, so it will be L over 2. Okay, that's all for this video. Thank you.